Good morning, everyone. My name is Akila. Today I'm going to present my Fog and Edge project based on task offloading in mobile edge computing using deep reinforcement learning (DRL). This work is based on the IEEE paper Deep Reinforcement Learning for task offloading in mobile edge computing systems. Mobile devices like smartphones and IoT sensors often need to run heavy computations like AI interference or large data processing. They can either process tasks locally or offload them to nearby edge servers. The challenge here is edge nodes have limited capacity, and if too many devices send tasks to the same node, delay grows and some tasks miss deadlines too. Devices don't know real time load at each node when making decisions. The paper solution is to use DRL so that the devices learn from experience how to make the best uh, offloading decisions and deciding whether to process locally or send to which edge node without needing full system knowledge. The problem here is the traditional methods have limitations like centralized approaches require global knowledge, not realistic and fast changing networks. And simple distributed methods often can't adapt quickly when load changes. The paper's DRL method is each device observes its task size, queue delays, and recent load history of edge nodes. It uses a DRL agent to select actions, local processing, or offloading to a specific node. It learns over time to minimize long term cost, which includes delays and penalties for drop tasks. Coming to the implementation, I implemented this as a Java based simulation. The flow matches the paper's methodology: observe, decide, measure cost, learn, and improve decisions. My simulation models are multiple mobile devices generating tasks, multiple edge nodes sharing processing power, realistic deadlines, and queue delays. Coming to the code implementation, we have the all key files in SRC. First one is the DRL core, which includes DRL agent.java, the brain of each mobile device, mapping states to queue values for actions. And we have neural network implements the queue network and replay buffer and experience. Java store past experience for replay, just like papers replay memory and decision policies like DRL task offloading policy and greedy task offloading policy, the main DRL based offloading logic, and a baseline method for comparison similar to the paper's greedy or random benchmark, and environment simulation like MEC environment.java and simple DRL simulation.java. These are simulates the system model like devices, edge nodes, wireless links, queues, and deadlines. Simple DRL simulation.java runs simulation loop. For training and evaluation, we have DRL controller.java and DRL task offloading evaluation.java. DRL controller coordinates agent training similar to the edge node trainer in algorithm 2 of the paper. And DRL task offloading evaluation runs evaluation and compares DRL variants. For metrics and visualization, we have task offloading metrics and results visualizer. Task offloading metrics tracks delay, drop ratio, throughput. A results visualizer generates performance charts. And we have two script files here. Setup dependencies is for automating project setup and dependencies, and run DRL simulation file is for runs all simulations with one command. After each execution, results get stored in the results folder, and we can see images in the data. A new folder gets generated. Let's go to the execution. With this one command, it runs all the commands in that file. You can see energy consumed for mobile 1, 2, and edge server 1. is for mobile, another, and the cost execution in cloud. For this, we are running all the simulations, and this is a recent one in the data. We had three images like energy consumption, uh, execution time chart, and network usage chart. This is the recent file based on the timestamp, we can say. Here we compared a simple and learnable versions. After comparing, the key findings are the learnable version has the lowest drop ratio and fewer missed deadlines, and it has a better resource usage and efficiency. After implementing, I can say that DRL has the better efficiency. In summary, I can say that I implemented IEEE's paper DRL based distributed task offloading algorithm entirely in Java, and the structure mirrors the paper's architecture like environment simulation, DRL agent training, replay buffer, decision policies, and evaluation. And the results confirm that DRL significantly improves performance over greedy or random approaches. Thank you.